Hello dear students of 10th standard. This is a diagram based question paper in which I have selected the first three chapters related to chemistry, and they are based on the science part 1 textbook. All diagrams I have selected are very important from the point of view of the examinations. Maybe it is SA1 or maybe it is your annual exam. Now let us consider the first diagram, which is the reaction between the acid and the zinc metal. When dilute acids are added to the zinc metal, there will be a displacement reaction. Hydrogen gas which is released is taken out through the delivery tube and it is passed into the soap solution and forms the hydrogen gas bubbles. This much is well known to everybody, and this hydrogen gas is tested by using a burning candle. It's very clear in the diagram. You may be asked to draw the diagram and there may be some questions related to the diagram. Now let us see what kind of questions can come in this part. Name the element which displaces the hydrogen from the acid. The element here what we have taken is zinc granules on which the dilute acid is put. So zinc is more reactive than the hydrogen. It displaces the hydrogen gas from the acid. What is the test for hydrogen gas? The hydrogen gas being a combustible gas, it explodes with a pop sound when there is a burning candle or flame near it. When it comes in contact with some flame, it gets exploded with a pop sound. Now the third question is, if we take the concentrated sulfuric acid instead of the dilute hydrochloric acid or dilute sulfuric acid, what will be the result? So the sulfur dioxide gas will be formed because it gets oxidized. So instead of hydrogen gas, we will see sulfur dioxide gas getting formed over there. Fourth question is like, what is the function of soap water in the experiment? The soap water helps to form the hydrogen gas bubbles which will come out flying easily. So that is the answer for the question. So this diagram is there for the exam to draw as well as to label, learn the labeling of the parts and also learn the parts and their functions related to it. Now let us move to the diagram number 2. In this diagram, iron metal which is red hot is taken and the steam is passed into it. Iron forms iron oxide and releases the hydrogen gas. Now let us see what are the types of questions can come out of this. Which element displaces the hydrogen gas from water? The same way iron displaces the hydrogen gas from water. But the iron should be red hot because iron is less reactive, and the steam should be there, not the cold or hot water. And then the question is, by what mechanism the hydrogen gas is collected? That is called as downward displacement of water. Because hydrogen is lighter, it moves towards the top of the inverted tube and it gets collected at the top. The bubbles are nothing but the hydrogen gas bubbles. They displace the water downwards and they get collected on the top of the inverted tube or collecting tube. What is the function of glass wool? You can see here the glass wool is soaked in water. When it is heated, it releases the steam and it acts as the source of the steam. Name the type of reaction involved and write the equation also. The type of reaction is the displacement reaction because iron displaces the hydrogen from water. And the reaction is Fe plus H2O gives Fe3O4 plus H2. You can see the reaction here. 3Fe plus 4H2O gives Fe3O plus 4 which is a solid, and 4H2 that is a gas. Now you can refer to the other reactions. Potassium and sodium, they react with the cold water and form KOH and NaOH. They are nothing but the hydroxides and give out the hydrogen gas. But when we move to the calcium, calcium is like, it is little bit less violent compared to potassium and sodium and forms the calcium hydroxide, but there will be bubbles of hydrogen gas and the calcium pieces will be floating along with the bubbles because the bubbles make it lighter. Magnesium does not react with the cold water. It needs hot water to react because it is lesser reactive compared to the above three. Now when we move down, aluminium, iron and zinc, they do not react with the cold water or hot water. They react only with the steam, and even the metal should be heated to red hot. Aluminium and iron and zinc will be heated first and then they react with the steam. So it shows that when we move from potassium, then sodium, then calcium, then magnesium, then aluminium, iron and zinc, there will be the reactivity which is in the decreasing order. Now let us see the diagram number 4. In this diagram, the ferrous sulfate is heated in a test tube and the smell of the gas which is released is taken by the experimenter. Now the questions are like this, and you just observe this also. There is lead nitrate in the test tube and a brown colored gas is getting released. So these two reactions have to be observed carefully, and let us see the questions related to these experiments. Name the gases produced when ferrous sulfate is heated. The answer is sulfur dioxide SO2 and the sulfur trioxide, that is SO3. Name the gas which is produced when lead nitrate is heated. The gas which is produced is the brown colored nitrogen dioxide NO2 is released when lead nitrate is heated. Name the type of reaction given above. In both the reactions, it is found to be chemical decomposition or thermal decomposition because the single reactant gives rise to the two or more products. For example, iron sulfate forms three products: Fe2O3, ferric oxide and sulfur dioxide, sulfur trioxide. And lead nitrate will give lead oxide and nitrogen dioxide and also the oxygen gas. Now, whether these two reactions are exothermic or endothermic. The reactions above are endothermic because they absorb the heat. They need the heat. Now let us see diagram number 5. In this diagram, you can see the electrolysis of water. It is also called as hydrolysis of water. Now let us see the questions which can appear for the same diagram. Why oxygen gas is liberated at the anode? Oxygen is liberated at the anode and hydrogen is liberated at the cathode. Why? Oxygen, being negative ion, gets attracted towards the positive anode and then it is liberated as oxygen gas. Now, the chemical equation for the above reaction is H2O gives H2 plus O2. 2H2O gives 2H2 plus O2. In this reaction, is this reaction possible with the distilled water, and why? No, the distilled water does not get ionized without adding the acid or any salt to it. So it cannot conduct the electricity. There is no question of getting the electrical dissociation happening with the pure, means 100% pure distilled water. So there is no electrochemical reaction taking place in the pure water. If there should be any reaction, we should add either the acid or any ionizing salts into it to make the water to undergo electrochemical reaction. Question related to this, fourth question is, why are the volume of gas collected above at the cathode and anode are different? Water molecule, as we know, has hydrogen and oxygen in the ratio 2:1 by volume. So the gas above in the cathode is hydrogen and gas above in the anode is oxygen. They are found in the ratio 2:1. Hydrogen will be always double the volume of the oxygen collected. Let us take the glance at the diagram number 6. Here you can see there is sunlight which is falling on the silver chloride, and the questions related to this is, name the kind of reaction and give the reasons for your conclusion. This is a photochemical decomposition process, as the chemical compound, that is silver chloride, decomposes in the presence of sunlight into silver and chlorine. Now write the chemical equation. AgCl gives Ag plus Cl. Two products are formed, so it is decomposition. We need light, so the photochemical decomposition. Now after the reaction, what is the product found in the china dish? In the china dish, the white shiny silver metal will appear as the chlorine, being gas, escapes from the reaction mixture. Now name any chemical reaction which happens in the nature which is similar to the reaction above. Means name another chemical reaction which is a photochemical reaction. The answer is photosynthesis in plants is also the photochemical decomposition which happens in the nature with the help of light. Now diagram number 7 we are going to take here. Here there is a reaction of bicarbonates and the carbonates with the hydrochloric acid. Now in the test tube number A, there is a reaction mixture, dilute hydrochloric acid and the sodium carbonate is being taken. If you take sodium bicarbonate also, same thing happens. Both will be similar. They release carbon dioxide which is taken out through the delivery tube, inserted into the cork, and that is passed into the test tube which contains the calcium hydroxide solution. Calcium hydroxide solution is also called as lime water, and lime water is colorless basically, but when it comes in contact with the atmospheric air which contains carbon dioxide, it becomes little bit cloudy. And if you pass carbon dioxide thoroughly into the solution, it becomes more and more milky. Now the questions related to this come in this way. Name the gas produced when sodium bicarbonate or sodium carbonate react with the hydrochloric acid. Now the answer is carbon dioxide gas. How can we test carbon dioxide gas? The carbon dioxide gas, when passed into the lime water, that is calcium hydroxide solution, turns colorless solution into milky, because calcium hydroxide, which is colorless, forms the calcium carbonate, which is white precipitate, so it appears to be milky. Third question is, what happens if we continue to pass the carbon dioxide into milky lime water, and why? If we continue to pass the carbon dioxide into milky lime water, it becomes colorless because calcium carbonate forms the calcium bicarbonate, which is soluble in water and becomes colorless. Now if we take sodium carbonate instead of sodium bicarbonate, what will be the result? The sodium carbonate also forms the carbon dioxide gas with the hydrochloric acid. Now let us consider the diagram number 8. In this diagram, you have two sides which represent the H plus ion concentration in the left side and OH minus ion concentration increasing from 7 to 14 on the right side. Now based on this pH scale, this is a pH scale, it has the numbers from 0 to 14. In the center there will be 7. Below 7 it shows the acidic nature. Above 7 means it is the basic nature solution. What does P in pH scale stands for? P stands for potence, or it is the meaning, the power of hydrogen ion concentration in the given solution. What is the range of pH values on pH scale? pH scale has numbers from 0 to 14. pH values below 7 stand for acidic. pH 7 stands for neutral. pH values above 7 stand for basic. Even in 0 to 7 range, 0 to 4 means strong acid. 4 above till 7 is weak acid. From 7 above 7 till 11 it is weak base. Above the 11 number till 14 it is strong base. Now let us consider what is the relation between the hydronium ion concentration and the acidic nature. Hydronium ion is nothing but H3O plus. It is same as H plus. H plus plus H2O with a water molecule becomes hydronium ion. H plus ion is not a free ion, so it will be always H3O. Higher the hydrogen or hydronium ion concentration, lower is the pH value. So if pH value decreases, acidic nature again increases. It is because acidic solutions contain more hydrogen or hydronium ion in them. So if hydrogen ion concentration increases, pH value decreases. They are inverse to each other. Now, why the solution becomes neutral at pH 7? The solution at pH level has equal number of hydrogen ion and the hydroxyl ion. Hydrogen ion is H plus ion, hydroxyl ion is OH minus ion. H plus or H3O plus hydronium ion is same. Both will be present more in the acidic solutions, so the pH will be less for acidic solutions. Hydrogen ion falls in the basic solutions, so the pH value increases in the basic solutions. Now let us consider a very important diagram number 9. It is about the electrolytic refining of the copper. What is electrolytic refining of copper? By using electrochemical process, the impure copper is converted to pure copper by removing the impurities. It is called electrolytic refining. What is the electrolyte and which electrolyte is used in this experiment? The solution which passes the electricity through it is called as electrolyte. Here the copper sulfate solution is taken as the electrolyte. Now what happens in the anode when electricity is passed? At anode, The anode being the impure copper metal, it loses the electrons. It loses the electrons and becomes copper 2 plus ion. Ion being free, it flows in the solution, copper sulfate solution, that is electrolyte, and it reaches the cathode. As the cathode is rich in electrons, after losing electrons, it needs the electrons. So the ions will move towards the cathode, being positively charged. Why is copper getting deposited at the cathode? That is the fourth question. Because the copper ions in the solution get attracted towards the cathode, they will move towards the cathode, gain 2 electrons and become metallic atoms and get deposited on the cathode. See, Cu plus 2 plus ions plus electrons will form the copper metal. E minus, it should be electron. Now let us consider diagram number 10. In this diagram you can see, in the blue colored copper sulfate solution, iron nail is dipped. After some time, you can see the changes in the copper sulfate solution. And the second mixture is iron sulfate solution with the copper wire dipped in it. Let us see the questions related to it. Write the chemical equation for the above reaction. There will be only one reaction, that is Fe plus CuSO4 gives Cu plus FeSO4. Because copper plus FeSO4, there won't be any reaction. Cu plus FeSO4 will not happen because copper is less reactive. It cannot displace the iron from iron sulfate. Name the type of reaction which is above. It is the displacement reaction where a highly reactive metal, that is Fe, displaces a less reactive metal, that is copper, from its salt, that is copper sulfate solution. Which is more reactive metal in this reaction? Iron is more reactive metal and displaces the copper from its sulfate. But the copper wire in the iron sulfate will not show any change even after some time. So there is no displacement reaction in the second reaction mixture. So copper is again proved to be less reactive metal. Now if we take the fourth question, why does the blue color solution changes to green and the color of iron nail changes to red color? The blue colored copper sulfate changes to iron sulfate, which is green in color. So the blue changes to green. And the brown colored metal, which is iron nail, gets deposited by the red colored copper metal. So it appears to become red after some time, and there will be change in the color in the iron nail. And if the question is reversed, why there is no change in the copper wire color? Because there is no reaction happening over there. Copper cannot displace the iron. There is no change in the color of the copper wire. So here we conclude the different kinds of questions which are related to the important diagrams given in your textbooks. Study for the exams and study all the questions and answers which can be based on application level, all based on the diagrams in your textbook and the experiments conducted related to them. Best of luck for your exams.